Now that we've got the basics down about non-permissible values and a few other things like that, let's start actually proving identities because that's the basis of this entire unit. Now, what's the point? Why do we want to prove identities so much? Well, one of the reasons why is here. We can rewrite and simplify trigonometric expressions. Do you remember when we went into that graphing thing and we had some sort of incredibly huge, long formula that we had to throw into the calculator? Wouldn't it be nice to reduce that down just to a couple of simple trigonometric expressions? That would just save our skin, wouldn't it? Well, that's what identities are used for. The other thing is solving. We solved using graphing so far, but oh my goodness, wouldn't it be nice just to kind of rearrange things, make it nice and simple, da-da-da-da, look at the unit circle, you're done, right? That's the whole point. The other thing is to prove other trigonometric identities. So somebody says, oh, well, this trigonometric identity is true. Yeah, prove it. Now you can. Right? And of course, what I'm going to do right now is develop new identities coming up. Now, what's cool here is the basis of the entire chapter is actually this third bullet right here. That's what we're going to do mostly based on all of the stuff that I'm going to learn you. All the stuff I'm going to learn you or teach you, right? Okay, so let's look at this. Here's our first thing that I want to do. I want to prove the secant squared identity. Well, wait a second. What is the secant squared identity? Surprising enough, you've seen it already. Watch this. Remember this page from a previous podcast? There it is right there. Right there. There it is. Secant squared actually equals to 1 plus tan squared theta. But where the heck did they get that from? Well, let me show you. That's what this is all about. Now, first thing that you want to do, always start with the basics. Start with what you know. One of the ones that you know is this one, and the other one you know is this. You know that secant is 1 over cosine. So, starting from here, this is going to freak you out. Watch this. This is cos squared x plus sine squared x equals to 1. There's Pythagoras. Again, a squared plus b squared equals c squared. The c squared, of course, being the unit circle of 1. So, here we go. How do we do this? Have you noticed something interesting? You've got a 1 over cos x here. Wait a second. What does that also mean? That means you could start playing around with this. You got it. You can start playing around with this cos squared x. Let's see if we can actually make something look similar to this. Well, let me just show you a little bit of an insight. If you're dealing with secant squared x, which is this guy right here, which is what you're trying to find, isn't that the same as saying 1 over cos squared x? There's your little trick. Let me show you what this trick is. If you divide everything here by cos squared x, so what you do to the left side, right? You do to the right side. Oh my goodness. Look, there's your cos squared x right there already. So the cool thing is you've got this already equaling to, guess what? Secant squared x. Wow, is it that simple all the time? You bet. Now watch this. That cancels with that, leaving you 1 plus sine squared over cos squared, of course, you know, is tan squared x, which is exactly what we had at the beginning of the unit. Isn't that cool? That's how this works. Oh my gotcha, you're kidding me. No, I'm not. We'll do another one. Look at this. I'm going to try to develop the cosecant squared identity. Now, this time I'm not going to tell you, I'm not going to flip back to the previous podcast or the previous slide and show you what this is. Let's just use our brain, okay? Hardest thing in the world, man. I like having a brain. It's fun. Okay, start with what you know. You know that cosecant x is 1 over sine. So if you actually squared this, right, this is the same as saying 1 over sine squared x. That's why this comes into play. As soon as you see the squares, it's automatically Pythagoras. Okay, so there's cos squared x plus sine squared x equaling to 1. Oh, how lovely. Look, if you divide everything out by sine squared x now, this is what you got. That's what you're after. You're after making it look like this. But what you do to the right, you got to do to the left. You betcha. Now check this out. Check this out. That cancels with this. You know that this already is our cosecant squared, which is halfway there, right? That's what we're after. Okay, so here's cosecant squared x. Beautiful. That cancels out to give you 1. Cos over sine, isn't that cotangent? But yeah, don't forget it's cotangent squared x. There is your identity. Want me to prove it? Let's go back to that slide at the beginning of this unit. Lo and behold, it's right there. Oh my gotcha, you did it right. Ladies and gentlemen, that's the introduction to identities. That's how you're going to solve every single identity from here on in.